This presentation covers an introduction to facade systems used together with light steel framing. So what types of facade systems may be used? Well, brickwork is one of the most common systems, and it's generally ground supported for up to 4 stories height typically. Insulated render is used with sheathing boards and insulation of various types. A variety of rain screen cladding systems may be used, such as clay tiles supported on horizontal rails and metallic or boarded systems. And generally, a lightweight facade system may be supported vertically by the light steel framework. And here we see a good example of a terraced housing scheme with light steel framing which supports 4 stories of brickwork. And here we see a typical isometric view of a brick-clad light steel wall system. On the outside, the brickwork coursing with the butterfly ties connected through to vertical runners that are screw fixed through the external insulation to the light steel C-sections, which also have mineral wool between them, and plasterboard on the inside. So why is restraint to brickwork facades important? Well, brickwork is laterally supported by the light steel structure, but the vertical load from the brickwork has to be supported on foundations. In order to provide restraint, vertical runners are placed at typically 600mm spacing and are screw fixed to the C-sections through the insulation. Or alternatively, special wall tie bracket systems may be used. At windows and door jambs, vertical C-sections are detailed at an offset around the windows and doors to fix the vertical runners and to provide for additional ties. And wall ties are located in the runners every 5th course of brickwork at 375mm spacing and every 3rd course around windows. And here we see a view of an insulated render cladding system, in this case without a cavity. On the outside you'll see the polymer modified render system bonded to the rigid insulation board with a breather membrane and a sheathing board fixed to the C-sections with mineral wool between, and 2 layers of fire resistant plasterboard are provided on the inside. And this is a view of a university building which includes both brick cladding and insulated render cladding, as you can see. So regarding insulated render facade systems, they use a variety of insulation bonded or screw fixed to sheathing boards. Suitable sheathing boards are cement particle boards, calcium silicate boards or moisture resistant plasterboards. And suitable insulation materials are foil backed polyurethane or phenolic board or expanded polystyrene. For housing projects, NHBC require that a drainage cavity is used in the insulated render system, but this is not generally used in other building types. And here we see one example of the use of a drainage cavity in insulated render. From the inside we can see the plasterboard, then the mineral wool between the C-sections, then the external insulation, and a cavity between the insulation and the sheathing board, together with a rendered facade. Rain screen cladding systems are in the form of boards, metal panels, clay tiles, etc. And they generally have rails that are fixed horizontally or vertically through the insulation to the C-sections to support the cladding. Sheathing boards are required to provide weather resistance, as the cavity generally behind the facade is ventilated. And some cladding systems require helping hands or extended brackets to fix to the sheathing board to support the cladding. And generally, rain screen cladding systems are relatively light, less than about 50 kilograms per square metre, and can be supported by the brackets but heavier systems require other forms of details. And here we can see a rain screen system, in this case a large metallic panel that is screw fixed through the insulation and sheathing board to the C-sections. And that same system is shown here. So these large metallic panels are attached on these projecting metal and nylon pins to the C-sections that are themselves screw fixed back to the light steel framework. In this case, composite panels or sandwich panels are used to support horizontal rails and to which the clay tiles are fixed, and there is enough rigidity in the metal fascia to allow the fixing to be attached to the composite panel. And here we see light steel infill walling with pre-attached brackets to support cladding rails. And here are some typical U values of light steel walls with insulated render for two types of insulation: expanded polystyrene or polyurethane with different thermal conductivities as shown here. On the left hand side you'll see the thickness of insulation, and the numerical values are the U values achieved for the particular walls. To achieve a typical value of 0.2 watts per square meter per degrees Kelvin, 100 millimeters thickness of expanded polystyrene is required, or around about 80 millimeters of polyurethane insulation. However, the suppliers should be contacted for more specific information about these systems. And here we see the use of large pre-insulated wall panels being lifted into place. And on the right hand side, an internal view of that wall panel with the expanded polystyrene between the C-sections. So what do we learn about facade systems? Well, firstly, lightweight cladding systems of various types may be supported by the light steel walls. Secondly, brickwork is ground supported and is used up to 4 stories high. It's restrained by ties connected back to the light steel framing. Sheathing boards are required for rain screen systems, which can be installed by the light steel supplier. A warm frame is created so that the C-sections do not add to thermal bridging. And external insulation of about 80 millimeters thickness of polyurethane achieves a U value of 0.2 watts per meter squared per degree K to satisfy modern building regulations.